Hello, my name is Ikano McKim, and I am doing Lab 7, which is pretty much a briefing over the gravitational forces and how to plot that in Python, how to use Python to use big amounts of data and actually get a graphical representation of it. So let's start by talking about this first problem, which was asking me what the mass of the black hole is. And as you can see, I got this answer over here. And how did I calculate that? I just used the formula for force of gravity. The force of gravity is equal to the constant g times m1, m2, which are the two masses, and divided by the distance of those, the magnitude of the distance squared times the unit vector of the distance. I'll show you where I modeled it. It is over here. Yes. So over here, notice how I took the magnitudes of it, because if you went ahead and tried doing this, you have to take the magnitude because of the way it's asking for the question. So yes, that's how I calculated that answer. And now it wants me to ask to explain how net force is, or how these three are equivalent to these three. Oh, actually, before I do that, let me go ahead and run the video. We'll run the program so you can see. I went ahead and slowed it down. The black represents the net force, the red represents the parallel force, and the blue represents the perpendicular forces. As you can see here, I set my arrow 1, which represents the perpendicular to red, parallel to red. Arrow 2 is blue and arrow 3 is black. And if you can see where arrow 1 is equal to, okay, I'm sorry, so arrow 1 is actually perpendicular, arrow 2 is a parallel, but arrow 3 is, of course, the net force. So back to this. Here's the graph. I believe that's correct. I calculated the mass correctly, and mass depends on the net force of the system. And if the mass is correct, that means the net force is correct. And because the net force is correct, that means that the way I calculated it was correct. So I'm assuming that because wherever side my answer is correct, that my method of doing this is also correct. Okay, so it's asking me how do these relate to these three values, and my answer is that they are the same. Newton's second law, momentum's principle states that the change in momentum is equal to the net force times the change in time. If you divide by the change in time, you get the change in momentum over the change in time equal to F net, and that's exactly what we have here. So this is saying that this right here is equal to the net force. The parallel of this is equal to the net force parallel, and the perpendicular of this is equal to that. And so that actually contradicts the next question. The next question was asking how do they differ. Again, they're the same thing, so they cannot differ. Yes, so they cannot differ, and because they don't differ, I don't see how they're different. My suspicion is that the parallel and perpendicular may be computed differently, just because, as you know, net force is equal to the parallel component plus a perpendicular component. So that must also hold true for the momentum principle. The change in momentum is equal to the change from the x component, and the parallel component and the perpendicular component. So I believe these two add up to equal the change in momentum, meaning that it should still be valid. Okay. Let's see how much time I have. I have about 4. Okay, cool. So this last question was asking if I can bring it down. Come on, don't be stupid. Okay. Imagine that you have a black hole. So it's telling me that you have a new black hole with a new mass, but everything remains unchanged. And the question is there a way you can have a different mass than the one provided? And the answer is no, that's impossible. If you have the same, so let's break the components of the gravitational force into two sections. You have Well, if the gravitational force is the same, or if it's moving in the same motion, you can assume that the force is still acting. It's the same. And so how you get the same force? You have m1 times m2. If the mass of your star doesn't change, I'm assuming the mass of your star doesn't change, and you have the other component is the distance. The distance does not change. So your R variable and your M variables don't change. So the only thing that literally changes this whole problem um, is the mass, and if that changes, then the whole net force changes. So it is impossible for you to have the same motion but different mass. That wraps up my presentation. I hope I did a good job. Later. See you lab 9.